Hello everyone, one. And this video, I'm going to talk about momentum a little more. I will introduce what is called impulse. Mhm. And because in previous video we say that if your system is isolated, your momentum is conserved. Okay, isolate means there is no external force. But what if your system has external force? Okay, then this picture is already give you a hint. If your system has no external force, your momentum conserved. And if your system if your system doesn't have external force, momentum is conserved. Once you have external force, you will have momentum changed. Okay, this is we can you can see this from the formula of Newton's second law. Okay, Newton's second law is here. Okay, the vector sum of force equal to the change of momentum, and then we do a little arrangement of this formula. For example, okay, this is the Newton's second. This is Newton's second law, and then we multiply delta t over here times delta t. Okay, and when we will obtain this. Left hand side is delta p only, and right hand side is sigma f times dt. And then we do the integration. We do the integration. Okay, in the right hand side integration range is from initial time to the final time. And the left hand side is initial momentum and final momentum. Yeah, I understand that you haven't learned the integration, but just accept that. Okay, and then I call this term, give me a new name called impulse. Okay, impulse is just the summation f, summation vector sum of f, and do the integration with respect to time. Okay, during this time interval. Okay, this is called impulse. This is called impulse. Well, the impulse will lead to the momentum change. Okay, okay, because how to say? This the impulse lead to the momentum change. Lead to momentum change. Why is momentum change? Because this is the impulse, right? This is impulse equal to pi pf delta p, and then this is equal to pf minus pi. Okay, yeah, this is the integration trick. Okay, it's equal to pf minus pi. So if the system has external force, it will cause the momentum change. Okay, cause momentum change. And in most of textbook, it also give you a formula. It's called an impulse equal to sigma f average times delta t. Why this textbook give you this formula? It's because about this graph. Because of this graph, the graph in the center. And this graph, it means the horizontal axis is time, and vertical axis is a summation f. Okay, the summation f and dt, and do the integration. It means, okay, in later you learn the integration is physical meaning is finding the area under the curve, the area under the curve, the curve. That's the physical meaning of integration. Okay, you will learn that in first year calculus. Okay, but I have, but right now I know you haven't learned it, but okay, just accept that. The meaning of integration is finding the area under the curve. So this curve, this brown curve is summation f. Then it change with time, and the area under this curve, the area under this curve, the area under this curve is equal to the summation f dt, and do an integration from ti to tf. Okay, so your impulse actually you can say the impulse is the area. Okay, the area. And if I want to calculate this area, I always can find a summation f average. Okay, or I always can find a summation f average and times tf minus ti. Okay, I always can find a summation f average and times the delta t, and and this area and this area the area equal to this area. Okay, the area of this the purple area of pink red. The area of pink red is equal to the area of black. Okay, the black area is equal to the pink area. Okay, it's equal. That's the meaning of these two graph. Okay, the impulse, the area under this curve. Okay, I always can find the average summation f force and times the delta t, and the area is equal to the original one. I always can do this. Okay, I always can do this. Always. That's because sometimes we need to find the average force during this time interval. Okay, because to find the force, the summation force at each time step, sometimes it's very difficult. Sometimes very difficult. So we just do a little trick. Okay, I don't want to the detail of this summation f. I only want to know the average of the summation f. I only need to know the average. Okay, I don't want to write. I don't need to know the detail. Okay, so it's kind of a trick. Okay, that's why it's lots of book give you this formula. The impulse equal to the summation f average times delta t. Okay, and this is very useful in daily life. In daily life, for example, your airbag. Why? Okay, okay. This is just what I explained. Okay, okay. The airbag. Why we need the airbag? Okay, because with your airbag, the airbag will extend your time on collision, and then you can and increase the time of collision. It will reduce the force, the average force exert on you during the crash. That's why you need the airbag. That's why you need the airbag. Also, the same concept. Some car design a crumble area, collapse or co-collapse area. In this crumble or collapse area, that's crumble area, yeah, collapse area or crumble area. And this crumble area, it also extend the time of a collision. If you extend the time of collision, it will reduce the average force when when your car crash on an object. Okay, this will makes you safe. It makes you safe. So the concept of impulse is really used in daily life. Okay, there's another example. Say, oh here, here. Uh, okay, I erased the I erased the example. Okay, here. Yeah, in boxing, okay, in boxing, a boxer moves away on punch. It also extend the time on impact. Okay, yeah, it's really true. In boxing, you move away from a punch. That's extending the time of collision, and it will let you feel less impulse or less the average force. Okay, and finally, for this video, we do a very simple example. Okay, a simple example. Okay, and if a car before it's going to minus 50 meter per second to the right, and after it hit the wall, it will the speed the velocity becomes 2.6 meter per second to the right. And Okay, what's the average net force exerted on car? Yeah, it's called average. The average net force. Average net force. So just like I said, the impulse equal to delta change, equal to momentum change. Mm, let me see. Okay, the impulse equal to the momentum change. So, and it's equal to the uh, average force, average force times delta t, average force times delta t. And be careful. One thing I want to address is impulse is a vector quantity. Impulse is a vector quantity because be careful. So it will has the x component, y component, and z component. If it's a 3D problem, it has three components. Okay, so it's equal to its final state x component minus initial state x component, final state y component minus initial state y component, final state z component minus final state uh initial state z component. Okay, sorry. Okay, I'm not very clear right now. Okay, because it's very late. And mm, okay, and so it's equal to let's say because it's x component, so it's x component average times delta t. So, and then it's summation y component average delta t, and it's z component average times delta t. Okay, so it's impulse is a vector quantity. Okay, back to this problem. This problem, it's only, yeah, it's very simple. It's a one-dimension problem. You know, x direction, it goes to this way and bump in that way. So it's only one-dimension problem. It's x direction. So, okay, let's do it. So it's very simple. Very simple. So its impulse is only has x direction. It happen only on the x direction. So impulse x direction. Final state x component. Final state its velocity is 2.6 to the right. So we assume the right is positive, left is negative. Okay, right is positive and its mass is 500 kilogram times 6 and minus initial state. Okay, initial state, the mass is the same. And what's the velocity? Velocity is minus 15.0. Be careful of this sign because we said the left direction is negative, right direction is positive. Okay, this is your chain. It's your this is your impulse, and the value is. I don't want to just let me. I just tell you the value is. Mm, okay, AA00. Okay, your impulse on x direction is AA00, and it's equal to force x component of force, and its average of force in x direction, average force in x direction. Okay, and times delta t, and it said correlation time is 0.50 seconds. So its average force in x direction, and its average force in x direction, average fx, okay, is equal to AA0 divided by 0.15, and its value is, let me check, 5866.6, and it's Newton. Okay, so it's average force in x component. Average x component force is 58,666.67 Newton. Okay, so that's the example, very simple example of the impulse calculation. Okay, be careful, impulse is a vector. Okay, its name sounds like impulse. The name sounds like a scalar quantity, but in fact, the impulse is a vector quantity. Okay, it's pretty much about the impulse. I hope you understand it. Okay, see you next time. Okay, bye bye. Bye 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 bye. See you next video. Bye bye.